So to start it off, we're going to talk, like I said, about a proposal from the Digital Securities Initiative. The Digital Securities Initiative is a project. It's not a company of its own. It's a collaborative project that many companies in the crypto ecosystem can and hopefully will participate in. But it started by Confusion Capital. And by the end of this hour, you'll understand why we did that. So to start us off, so essentially what we're trying to do is figure out the secondary market structure for tokenized securities in DeFi. What does that mean? For anyone who's heard of the market structure bill, there's a bill that's making its way through Congress right now. People are not super optimistic about it passing this cycle, but at some point, probably something like it will, which it's called the market structure bill, and it basically figures out what should the new regulatory paradigm be for crypto. But it's mainly focused on the centralized entities within crypto. It's focused on like the exchanges, for instance. It doesn't really answer the question about how we should regulate DeFi. And so we've really jumped in to try to get ahead of that and figure out, how does it make sense to regulate DeFi? And in particular, how does it make sense to approach tokenized securities, like tokenized Apple stock, tokenized bonds, et cetera, in the context of DeFi? And there's a lot of sticky questions there. So in the traditional market, financial institutions hold your assets. And so it's been very natural for those to be the entities that are regulated, that are required to fulfill a whole bunch of different roles on behalf of the government in order to prevent criminal activity. So they're the ones in charge of knowing your identity, monitoring your transactions, reporting on your transactions, and then in some cases limiting your transactions if they believe that you're committing some sort of criminal activity. In a DeFi situation, you hold your own assets and you operate your own transactions. So there's this big question of like, well, okay, then who's going to do all these things that the government is used to being able to do or used to relying on someone to do? Who knows your identity? Who monitors your transactions? Who reports on those transactions and who limits them? So again, normally this is done by a financial institution, and we've spent the past year thinking about this really from a first principles kind of mindset. Not studying the current regulations very closely, just thinking, well, let's look at this new technological paradigm and think about how should it work. And so we have a proposal that basically creates different regulated entities called identity keepers, transaction monitors, and then transaction filters, something that happens in a smart contract that basically answers these questions. And by the end of this talk, you'll understand what all those things are. So for a little bit of background, if we don't figure out a comprehensive way of doing this, the industry is just going to sort of cobble together different approaches to do its best to comply with current regulations. And that's what's already starting to happen. So as tokenized securities are starting to be issued, what we're seeing first is this whitelist approach. Okay, so every single issuer creates its own whitelist and says, okay, if you want to hold our tokens that we've issued, you have to go through KYC with us and get on our whitelist in order to hold this token and transact with it. And that's kind of a way of, in a way, mimicking the TradFi approach of treating themselves as a financial institution. But the problem with this is as you get more and more whitelists, you get what we lovingly term the whitelist catastrophe. Okay? Imagine that these are your holdings. You now have to have gone through KYC a zillion different times to be on all those different whitelists. Okay? But it gets even worse. Imagine this is your DeFi application. Well, a DeFi application, it's a smart contract, it has an address. That address also has to be on the whitelist of every single security token before those tokens can be deposited into that DeFi contract. And so now as a developer, you have to get on every one of those whitelists, and you have to comply with all the different requests of every single different token issuer in order to satisfy them to get on those whitelists. You have to add further restrictions to your DeFi app for them to be willing to whitelist you. And so we think that this makes the DeFi development process sort of the opposite of what it is today. The sort of free, permissionless, composable DeFi Legos we're used to would quickly grind to a halt if you end up in this situation. So that's sort of the first thing that we're trying to solve of many as we're thinking about all this. And in general, the simple idea for how to approach this that we were attracted to is what if there was some sort of single standard, the single standard nirvana, where you, as a user, you go through KYC once, and you're part of some sort of global system. Similarly, as a DeFi developer, you get one you get added to one whitelist or one certification or something, and you're part of the system overall, so you don't have to keep doing this over the course of time. And so that was one of the aspirations we had with this system. Now, if you think about it and zoom out, though, we're really talking about many different blockchains, right? It is not all just on one blockchain. So really, it'd be great to have a single standard that encompass all the different regulated tokens out there across different blockchains. But as you start to think about this, it's like, okay, well, what is the single standard? Who is it that sort of somehow manages this global whitelist and has all this information, right? You say, well, maybe the government has this information. Maybe every single transaction, you embed some information that's readable by the government. Anyway, I'll skip the history of how this was approached before with the internet. But obviously, we don't want that. That would be a surveillance nightmare. We don't want the government to be watching over every single transaction we do. You might say, okay, well, maybe it should be some private company. Maybe we privatize this, and instead of the government, it's like companies under competitive forces. But still, who is that? And do you really want them to have all that information? Also, they could be hacked by someone else. So even if you trust some big company, do you trust whoever hacks them 10 years down the road? Or they could be backdoored by a government, something we've definitely seen, even in this country. And so basically, we have to be very careful about who ends up with information in the system. So when you confront that, when you think about that for a while, you start to think, okay, maybe we need to really rethink everything. Maybe not everybody goes through KYC anymore. Maybe we have a situation like we have today with stablecoins. Today with stablecoins, you don't have to go through KYC to hold them on chain. We have this situation where everyone is pseudonymous, and we have blockchain monitoring companies that are watching the transactions, and somehow that seems to work. So far it seems like we prevent a lot of criminal activity with that system, and so you might start to think, okay, well, maybe we should just go the route of pseudonymity. The problem with this is what we call the doxing slow burn, which is basically if your transactions are pseudonymous, the more that you transact with people in person, like if you go to the grocery store and buy some groceries, you now discover that grocery store's, that teller's address, which you can probably then link to a bunch of other addresses that business holds, and you can see its financial flows and its financial holdings. But also, it can see that about you. The person who pays after you in line, they can figure that out about you. If you order some shoes on the internet, you're connecting your name and address, your physical address, to your blockchain address. And this is a problem. And so over the course of time, more and more actors in the system learn who each other are. Another end of the spectrum is, imagine you're like a large hedge fund doing a $300 million, TWAP trade over the course of a week. You start your trade, and everyone's, tracking your wallets, and you're quickly front run, right? Like, these are all problems we're not used to in the normal system, because actually the normal system provides us quite a bit more privacy in some ways than the blockchain. And we haven't really confronted this problem in the context of DeFi, because it's mostly just people like in their offices and living rooms kind of doing these speculative trades where there's very little real commerce. And so there's not a whole lot of connecting your real identity to your blockchain identity. But over the course of time, I at least really think that blockchains could be used in the ordinary economy. And so I think that we're going to see a whole lot more problems. So we took on the challenge of, okay, can we do something that actually affords quite a bit more privacy than the current system actually allows with the pseudonymous setting? So that brought us back to, okay, how can we do the single standard nirvana? And there's one other constraint that we were concerned about, one other possibility, which I call the deglobalization letdown, which is basically, okay, you can imagine a situation where it's like, okay, we figure out some single standard, but every single country has their own single standard, and they're all different. And we sort of replicate the same situation we have in traditional markets, where it's very difficult to get access to every single market around the world, and you have this very fragmented set of liquidity pools as opposed to one global liquidity pool. We think that one thing that's so amazing about crypto and DeFi today is the single global liquidity pool that everybody can access. If you imagine applying that to capital markets across all the different countries in the world, many of which do not have strong capital markets the way the US has, that could be really, really good for the world economy, we think. So we want to avoid this situation of separating everybody off into different portions. Okay, so the Digital Securities Initiative started last year and spent a bunch of time exploring this design space, thinking about, can we find a design that is private, accommodates regulation, and is global? And the question is like, is there any overlap between those? And when you start to think about them, it's like there's not a whole lot of obvious overlap. We found that there is a small amount of overlap. And so this is what we are here to report back on. We're super, super excited about the fact that there is overlap. We have found one design so far that fits all three of these. And we think that, probably there are other designs in that portion of the design space. And if someone figures out one of those, that could be great too. But in the meantime, we think this is the best way to proceed. So we've had conversations with the Department of the Treasury and with the SEC Crypto Task Force about this and gotten some pretty positive feedback. And so, yeah, we're excited to share this more publicly. In the interest of time, I'm going to skip that part. So, as a very, very brief history, in the past, securities were transferred back and forth on paper up until the late 1960s, early 1970s. And this is an actual picture of that happening. It turned into a situation that's known as the paperwork crisis, because we got to the point where there were just so many trades happening that it took too much time to actually transfer things back and forth on paper. The SEC decided to close the stock market on Wednesdays. So you could trade on Monday and Tuesday. On Wednesdays, just close the markets, spend all that time catching up on paperwork, and then you could open it again on Thursdays. And so we really just exceeded the transaction limits on paper. And this led to, in 1970, what's called the Banking and Securities Industry Committee coming together. A bunch of prominent folks from stock exchanges and banks got together and spent 2 years working very hard to figure out, what do we do about this? How do we solve this problem? The solution wasn't figured out by the regulators, by the SEC, but they did work closely with regulators. They testified in Congress and so on to work out the new system, which was to take all of that paper transfers and say, hey, what if we did this with a big computer? And this is essentially what gave birth to the Depository Trust Company and modernized the system. And so the Digital Securities Initiative is akin to that group, BASIC, the Banking and Securities Industry Committee. We're an industry group coming together to figure out a solution to this problem in coordination with regulators to try to chart a path for the future. So with that, I will hand it over to Andrew Wirth, who's going to talk to you about the system in broad strokes, sort of our overall perspective on the system. And then we have one further presenter that'll dive into the details. Thanks.
Thanks, Nevin. Hey, everybody. My name's Andrew Wirth. I'm one of the researchers here with Confusion Capital and with the Digital Securities Initiative. Quick background on me. Before joining Confusion Capital, I was with Goldman Sachs doing financial crime compliance, AML, and KYC. So it's been great to be with DSI doing research on this solution that Nevin's introduced. I'm going to just go ahead and give a brief overview of the solution itself, and then I'll hand it over to one of our other researchers, Billy, who's going to go into some of the more technical details. But going through this solution, the context to think about this is the secondary trading of tokenized securities. And as we started thinking about how this would work, we looked at the traditional financial system. And in traditional finance, regulators generally rely on financial institutions to implement controls and interpret regulatory objectives. And so, of course, in blockchains, there are no financial institutions to fulfill this role. And so that's the key problem, is who's going to take the position of financial institutions to do this job of interpreting and implementing controls for regulatory objectives. And as we thought about what this solution should be, we wanted to make sure that we did this in a way that maintained the permissionless and decentralized nature of blockchains that we care about. So that was a key consideration as we thought about our solution. And the starting point for this is this idea of a regulated zone. So we created this concept of a regulated zone that essentially embeds regulation and regulatory objectives on-chain directly. And in order to define the regulated zone, we came up with this concept of a compliance regime. So a compliance regime essentially sets all of the regulatory standards that fall under a particular regulator, like the SEC, and that specifically defines a regulated zone. Within a compliance regime, there's this concept of classifications. So classifications specify different types of risk, so regulatory risk, and each classification is made up of attributes that are elements making up this classification. And classifications themselves are applied to users and they're applied to contracts. So users and contracts can use these risk classifications to make decisions about interacting with one another. If a particular user, for example, becomes a high risk under a regulatory classification, a contract can decide to screen out transactions with that user. In order to implement this, we needed to create some key roles. The first role is this role of a self-regulatory organization. This organization carries out technical oversight on behalf of a regulator like FinCEN or the SEC. This organization oversees entities like an identity keeper. So an identity keeper is a role that we created to essentially collect the personally identifying information of particular users so that information can be used for compliance. Another role that we considered to be important was this role of a transaction monitor. So a transaction monitor's job is to observe the blockchain in real time, analyze patterns, and assess those for regulatory risk. And then the final role here is the role of a contract certifier. So a contract certifier's job is to assess contracts for particular risks and certify those on-chain. So this ecosystem, we really, for each of these roles, we envision this being an open market where different providers of these services can come in and play these roles and compete. So I'll just walk through an example of how this actually works in practice. And this particular example would be for anti-money laundering. So we start with a regulatory objective of anti-money laundering. That falls under this Bank Secrecy Act regime. So the regime defines the standards for anti-money laundering. The specific classification that we care about is money laundering risk. And specifically, money laundering risk is composed of attributes or transaction patterns like a structuring transaction pattern or a flow-through transaction pattern, which are essentially just patterns that indicate money laundering risk on-chain. So the transaction monitor takes that regime, they monitor the blockchain and observe transactions in real time. A user starts out as low money laundering risk. Let's say they conduct a transaction that indicates a structuring pattern, their money laundering risk increases. Finally, they conduct a third transaction that looks like a flow-through pattern, their money laundering risk increases to the point where a tokenized security contract screens out further transactions from that user because they're high risk. So when it comes to something like sanctions enforcement, this is something that we essentially assumed would or realized would need to be enforced by collecting certain elements of real-world identity. So something like sanctions requires the identity keeper to screen a user against something like a sanctions list. So in this case, an identity keeper collects that information, screens a user against a sanctions list. If a user's not on a sanctions list, they're low risk. If they are on a sanctions list, their risk increases to the point where a tokenized security contract would screen out further transactions with them. For a contract certifier, this example is something like a market integrity risk. So the classification would be checking for illegal foreign ownership of a tokenized security. The contract itself would need to screen out illegal users or foreign users who are not authorized to own a tokenized security. And the contract certifier would make sure that the contract itself has a token whitelist to screen out those users. If they don't have the token whitelist, their classification or risk increases, and users can assess the risk of a contract and essentially not interact with them so that their own risk profile doesn't increase. Another key requirement that regulators have is reporting. So transaction monitors themselves are responsible for reporting. They observe transactions, and when needed, they send reports to regulators. This is the solution as it works together. These are all the pieces as they fit together. So that's the high-level overview. I'll pass it over to Billy now. He'll go into some of the technical details of how this works.
All right. Thank you, Andrew. So Andrew introduced this picture. And so now what I'm going to do is I'm going to walk through the different components of this picture now that you have an overview and explain exactly how specifically each part works, all right? All right, so the first core of the solution, the workhorse, is zero-knowledge proofs, right? So what is the zero-knowledge proof? Well, I could talk a long time about that, but it's a way that allows us to prove relationships on hidden data, which makes them very good for privacy, and they're also very efficient because you can prove lots of relationships at the same time with the same amount of verification, okay? So if you're confused about ZK proofs, you can come talk to me in the coffee break, and I'd love to talk your ear off about them. All right, so the main component here, like we have this regulated zone. The gate to this regulated zone that really makes it work is this transaction filtering concept, right? So this transaction filter looks at the classification of the counterparty and accepts or rejects the transaction, all right? Now, on the user side, the transaction filter is built into their wallet, right? And it enables the wallet to be compliant. It allows the wallet to sort of keep the user within the regulated zone, and can protect them against scams or what have you. And basically, if on the user front end, it will even keep stop them from even seeing contracts and things that the user doesn't want to see, right? On the other side, we have the smart contract has a transaction filter. This will be the main focus of the talk. And it actually does the work of enforcing regulations, right? And what it does is when there's a transaction that's calling that smart contract, it is going to check that transaction and reject it if the classification of the person calling the smart contract isn't correct, right? Now, what is this specifically doing? Actually, all it's doing is validating a ZK proof, right? We're going to use the ZK proof the ZK proof is going to prove the classification, which creates a privacy shield between the user and the smart contract. So the smart contract doesn't need to know anything about the user in order for this to work. Now, if the user is of the wrong classification, what literally happens is that the user will not be able to produce a valid ZK proof of the correct classification, right? So if they try to create a ZK proof, it would not be valid, and the transaction filter will just reject the transaction. All right? So the main question actually then is how does the user actually create the ZK proof, right? How do we get this information? How do we get the information about the classification to the transaction filter, right? So it can do the verification. So we're going to first talk about the outer parts of this diagram, where we have the identity keepers and the contract certifiers, and they let users and smart contracts into the regulated zone, right? So how does this work? we use a technology called verifiable credentials, right? Which essentially allows one digital identity to certify something about another digital identity. These credentials can be verified by smart contract, but more specifically, they can be wrapped into a ZK proof, right? And so through this technology is designed to enable real-world assessments to be recorded on-chain, right? So it's about connecting the real world to the on-chain world, right? So how does this actually get used? Let's go look at sanctions enforcement again, okay? So we have the SRO, the identity keeper, and the user, right? These are three real-world entities, and all of them are going to have identifiers, all right? They're all going to have IDs, and the identity keeper will go through some sort of registration process that Andrew talked about, and then the SRO will give them a registration credential, okay? When the user goes through a customer identification process with the identity keeper, they check, hey, are you on a sanctions list? When that gets done, they will give them an identity certification credential, right? Now, both these credentials can be wrapped up into one single ZK proof, right? And then the transaction filter can check this and then goes, oh, okay, I just checked the ZK proof, therefore I know that you have gone through a rigorous SDN check or whatever, what other real world checks need to be done. Meanwhile, there's a privacy shield that protects the user from the transaction filter so that no one actually needs to know who the user actually is, okay? Now, great thing about this technology is it can be dynamic. What happens when a user is added to a sanctions list? Well, the identity keeper can see that, through real-world communication channels and go, haha, you're on a sanctions list, we're going to revoke your credential. And the X should be on the other side of the ZK proof. But yeah, the ZK proof will no longer be valid, right? After the credential is revoked, the ZK proof is no longer valid and the transaction will be rejected. So what happens on the other side of the diagram, right? We were talking about the users and the user side. What happens on the smart contract side? Well, we have a similar process, right? Except for the entity that does this process is a contract certifier, right? And this contract certifier is going to basically certify the correct classification of the smart contract under the regulatory regime, right? So they will check, okay, smart contract, are you a token or are you a DEX? Based on this classification, there's a bunch of requirements. Some of these can be functional requirements. The basic thing of example of a functional requirement is the transaction filter itself, right? Is there a transaction filter that's connected to the smart contract that's checking for the sanctions check or whatever else needs to be checked, right? And you can also check other things like, is there a transaction monitor guarding it? We'll talk more about that in the next slides. And this also probably would require some sort of code audit, right? The contract certifier can do the audit themselves or have someone else do the audit. Then check, there's not some backdoor that allows, North Korea to bypass that transaction filter, right? Now they can also check if real-world legal processes were filed, right? Like if we're talking about a tokenized security contract, if someone's doing a IPO on chain or something like that, they probably have to do something like file an S1, right? And the contract certifier can check that. Hey, did you file an S1? Yeah? Okay, cool. And that can be part of the classification process of the smart contract, okay? So this here is really about, removing sort of the problem sort of in DeFi that anyone can just post code, right? And then who do you hold responsible if something goes wrong? We don't really want the government to with how DeFi is today, just hold random people responsible for certain things. But this is someone voluntarily saying, yes, I have some amount of responsibility for what is happening in the smart contract, right? I'm going to tell you guys this is what this smart contract does. Right? And and it meets the requirements for what we agree for this classification for this smart contract. All right. So now we've talked about the outside, right? We've talked about how users and smart contracts are let into the regulated zone. Now we're going to talk about how the regulated zone is policed, right? How do we make sure that rules are, people follow the conduct that they're supposed to follow once they're entered into the regulated zone? Specifically, we're going to talk about the transaction monitor, okay? But before we can talk about the transaction monitor, we have to talk about something else. We have to talk about the Sybil problem, right? So a fundamental problem for policing activity on chain is the Sybil problem. A criminal can just create thousands of addresses, right? This brings two practical problems. One is identifying who these actors are. There are some tools to do this, right? Like if you look at how funds are moving, you can kind of guess, yeah, I bet this is one single entity that's behind all these things, but it's a bit of guesswork, okay? And also, on the other hand, is how do you take action against that entity, right? One thing, there's no way to identify that person to other people. It's more of a technical problem, but if you try to ban all the addresses, they can just create a new one, right? So it's hard to say ban someone from, it's hard to ban someone from an automated way if you don't have a way of identifying them, right? So we solve that with something we call pseudonyms, okay? So in our system, we have a cryptographic recipe for generating what we call a pseudonym, and this is generated from the user ID, the credential, and the smart contract, and you give one of each of these things, you get one unique pseudonym, right? And so every time the user transacts with a smart contract, it includes the pseudonym that it includes the pseudonym, right? Now, you might be wondering, well, why doesn't the user just include their ID, right? That should be a unique identifier. That's unique in this situation, right? But the reason why we have a pseudonym is to create privacy. So the pseudonym is not directly connected to the ID, right? Why is this important? This is important because of the slow doxing burn that Nevin was talking about, right? If a user posts the same identifier in every single transaction that they use, people are going to figure out eventually, I think this ID is going to be connected to this person. This pseudonym is not the same for all the smart contracts. There's a unique pseudonym for every single smart contract, right? And so the user's behavior for each smart contract is put in a little box, right? And so that whoever's watching that smart contract might be able to deduce something, right? But it's very localized, and they're not going to be able to deduce that then to the identity itself, okay? Now, to add another layer of privacy, we will do something else. We are going to encrypt the pseudonym in a way that the transaction monitor can see what the pseudonym is, but no one else can see what the pseudonym is, right? Now, of course, since we're now having a pseudonym and it's encrypted, we actually need to stick something else into our ZK proof, right? Because we will just have this the ciphertext here, and the ZK proof will test that it's not just some random string of numbers, that this is actually an encrypted pseudonym, and that pseudonym was generated by the proper cryptographic recipe. Okay. At this point, I want to say there's one other little detail to make this work, right? We are talking about this formula of like one user, one credential, one smart contract gives one unique pseudonym. That only works if every user registers with only one single identity keeper, right? And so the identity keepers will need some sort of communication system where they can sort of synonymously, communicate about who is registered with them. So we could say, you show them an identity document, and based on that identity, like when you in the real world, and maybe have your name, your document ID, and your birthday, and the identity keeper can hash all this information and post it in like a private database that the other identity keepers can see. And so if they try to register somewhere else, they can see that, right? And the identity keeper can go, oh, wait, you're already registered somewhere else, right? So this system might not be absolutely perfect, but maybe a student, someone can register 2 places. That will probably be called fraud, right? Punishable, real-world punishments would be involved, but as a user will certainly not be able to just go register with like 100 different places, right? So that you effectively solve the Sybil problem for what we need done here, all right? All right, so now I talked about pseudonyms and Sybils and everything like that. So now we can go talk about transaction monitoring, right? How is the pseudonym actually used, and how is that actually then used to sort of police the regulated zone? All right, so in this example here, we have the transaction monitor, and they have this off-chain risk evaluation database, right? This is a private database, and they will have profiles on all the pseudonyms, okay, for the smart contract that they're watching. So in this example here, this user pseudonym is ABC, right? So ABC refers to this user here. Okay, so let's go through the AML example again that Andrew talked about. Oh, first, sorry. If the transaction monitor, in order for them to effectively communicate with the transaction filter, they can publish classifications on the on-chain database, right? So think of like the private database is like their scratch work, and then if they need to make like a decision and take action, then they have the on-chain anonymized database that they use, okay? So let's now walk through this AML example, see how it works. So if the user issues a normal transaction, they have a ZK proof that the pseudonym here does not appear as on the money laundering database, right? The transaction filter verifies that and goes, all right, cool. You're not a money launderer. Great. We let the transaction through. And then at that point, the transaction monitor sees it, right? And it's a normal transaction, so they don't do anything, right? So no update on any database. All right, so the user now issues another transaction. Let's say this transaction is part of a structuring pattern, which just means that, as part of some sort of money laundering suspicious behavior. Well, again, the pseudonym is not in the money laundering database. So the transaction filter goes, all right, cool, ZK proof checks out, goes through, the transaction monitor sees it and goes, whoa, this is a bit suspicious, right? Bit suspicious. I'm gonna update my database, but maybe it's a fluke. I'm not gonna take action yet, all right? No update on the on-chain database. So the user now issues another transaction that's part of a flow-through pattern, all right? Which is another money laundering thing. Now, so again, the pseudonym is not listed as a money launderer. So the transaction verifier, the transaction filter verifies the ZK proof, lets it through. Now the transaction monitor sees this and goes, whoa, whoa, whoa. This is awfully suspicious, high money laundering risk. I'm going to take action. I'm going to post the hash of the pseudonym, hence the anonymous, why we call it the anonymized money laundering database. We're going to post the hash of the pseudonym and say, this is high money laundering risk. All right? Now, if the user tries issuing another transaction, they will not be able to construct a valid ZK proof that the pseudonym is not high money laundering risk. All right? All right, cool. So that's how. So we saw before here how the transaction monitor can police the regulated zone and take on-chain actions and stop a user from accessing a smart contract, right? Now, let's connect this to the real world, right, for a second. Because one of the things that's important is, that Andrew mentioned, is in traditional finance, there are reporting requirements that institutions need to do. Well, we can do these with the transaction monitor. Let's see sort of how this works. Suppose that the user issues a transaction and suspicious somehow, and it's the type of transaction that the transaction monitor needs to report. Like maybe the transaction monitor suspects that this is that this is actually someone stealing funds, right? Like maybe someone hasn't touched their funds for like 10 years, then all of a sudden it moves and it looks a little funny, right? So what they can do is they can just send a report to the regulator about this, okay? Now, we haven't talked about the cryptographic recipe for how to generate a pseudonym, but effectively, the pseudonym is essentially just an encrypted version of the ID itself. So it itself is a ciphertext, and the regulator can extract the ID from the pseudonym by essentially decrypting the pseudonym and realizing, okay, I now have the ID of this. So, and also we can list the identity keeper inside the little encrypted bubble inside the transaction, so the regulator can go and they know who to ask. They can go to the identity keeper and say, well, who is this ID? The identity keeper can say, well, it's Bob, right? Here's your address, and here's all the information you need to know, right? So it's not, the regulator doesn't have direct access. They have to go through, I think, the right amount of rigmarole, right? So this is, they can essentially, they have the tools to be able to figure out who is who. But the transaction monitor never needs to know who the identity, that's, the name of the person behind the pseudonym, right? Now, one thing I want to make clear, so if you remember, I was talking about how every different smart contract has a different pseudonym for the user, right? So in here, you have transaction monitor 1, looking at this contract 1, transaction monitor 2's, monitoring contract 2. The user has 2 different pseudonyms, pseudonym 1, pseudonym 2, right? And each transaction monitor doesn't really connect these things together, right? But they'll see this suspicious stuff, and they can send these reports to the regulator, but they can create, a database just, in the way that they already do, right? They have, the regulators have databases of suspicious activity reports, right? And they use this for investigative purposes and such, and they still have this ability to do this, right, underneath this system. All right, cool. So, all right, so we talked about now really, you got a sense of how the transaction filters work and how people are let into the regulated zone and how the regulated zone is policed by the transaction monitor. But we kind of been looking at fairly simple examples. One smart contract, usually when you interact with DeFi, you call multiple smart contracts. So let's consider a slightly more complicated example, a DEX swap, and see how this looks, right? So a DEX swap, the transaction effectively is going to be calling 3 different smart contracts. There's going to be, the token A, token B, and the DEX, that's actually doing the swapping, right? So here, the token A contract is going to have a transaction monitor. It's going to have a database and a pseudonym connected to there. Then the DEX will have its own transaction monitor, its own pseudonym, and it will have its own database. But in this example here, the DEX is a different classification of smart contract. So by the regulatory regime, the transaction monitor probably will have to look for different things, such as market manipulation, right? All right. And then, of course, the other token, it's a replica of, same situation with token A. It has its own pseudonym, own database, etc. One difference here, though, is we see these certified credentials again, right? Now you can sort of see how this is important. A tokenized security probably should only be allowed to be traded on regulated DEXs, right? That will probably be one of the rules that the regulator will enforce. So the certified credential allows the contracts to basically control with whom they're composed with, right? So they can make sure, like, oh yeah, don't deposit me on some sort of sketchy DEX. I need to be deposited on a regulated DEX. This is actually super important because you can think of if you didn't have this certified credential, you could have a really easy way to bypass all these, the transaction filter and all this stuff. You could just go take your regulated token, deposit it on a smart contract that just wraps it, strips off all the controls, and then just trades freely like an ERC20, token with no controls. That's not going to work, right? So these certified credentials prevent that from happening, okay? Now, the one thing I want to highlight is you can see all the work that the ZK proof is doing. This is a bit of the efficiency I was talking about. There's a whole bunch of different checks, but this all gets wrapped up, and the ZK proof verification time is always constant, right? Which is super great. And also, I want to say, like, the ZK proof, what it's doing, it's proving multiple classifications, essentially. Like, look at all these classifications it's proving. It's proving the classification to each smart contract of the user, right? And it's also proving the classifications of the other smart contracts, etc. All right, cool. So that's how the regulated zone works, right? We've seen now a couple examples. Now I want to highlight, shift gears slightly, talk about privacy. Nevin's talked about the importance of privacy, and well, there's a funny thing. If you've noticed, if the transaction monitor is doing the analysis and the identity keeper is doing the identification, actually, privacy pools and privacy chains can be compliant, okay? So, let's consider like a privacy chain, something like Aztec Aleo or Zcash. We've got someone from Zcash here, right? So in these smart contracts, in these chains, smart contracts have encrypted state, okay? And so that's what keeps it private, okay? And then the transactions are also encrypted. Now the realization is that, well, let's just make sure that the transaction monitor has the ability to decrypt the state of the state and the transactions for the smart contract that it's guarding. All right? This is a great idea. Now I want to highlight though the subtlety here, right? Nevin talked about the surveillance nightmare, right? The giant eye that can see everything. Before doing what we're doing, if you're just to naively have a transaction monitor guard a private chain, you would just give one transaction monitor the key to decrypt the entire chain, right? But this is not great from a privacy standpoint, right? This is a central point of failure. If they get hacked, all that data gets leaked. That's bad, right? So here, what we have is we have a logical way to divide up the privacy chain, smart contract by smart contract, and say, oh, well, this transaction monitor looks at this part, this transaction monitor looks at that part, and they're working their own little bubble, and and they can just report whatever suspicious activity they need to for the regulator, right? So it's really kind of funny that at this point we don't need much extra to actually enable these privacy chains, right? So in this case here, the transaction monitor completely do their job, but the general public sees absolutely nothing. They just see gobbledygook on the chain, right? We can have truly private transactions and regulatory compliance, right? All right, so now we come back to this picture here, and we say, we have this picture, we have all these things, and the glue that connects all of this is the regulatory regime, right? Like this is what we call an ontological standard for compliance, right? It is a data standard that allows different identity keepers, and different contract certifiers, and different transaction monitors, and different transaction filters to all interoperate together, right? And what I mean by ontology is it's not only a data standard, but the meanings behind the data are the same, right? You have the registration process of the identity keepers and the contract certifiers and transaction monitors. They make sure that there's like a level of quality at each stage, right? And so now, if an identity keeper, every single classification means the same thing to everybody, right? And this is what enables compliance. All right, and this is also what prevents some sort of monopolization, because we can have this like competitive environment and this is what really effectively solves the whitelist catastrophe that Nevin was talking about in the beginning. Okay, and the glue behind all of this is the classification regime. All right, so the next thing I want to talk about is how do we actually deal with the deglobalization letdown, as Nevin talked about. This classification regime works great for a single regulator. We've got many different regulators just within the US, all right, and also internationally. Well, the thing is you can have multiple regimes, right? We envision that each classification regime is going to be identified by a number, right? And so all the actors can say, well, we're going to follow this class. You're classified as such underneath this regime, but you can also do several classifications simultaneously under different regimes, right? And this can be all done under the hood. So for example, like in a normal DEX between, say, tokenized Apple futures and tokenized oil futures, tokenized Apple stock and tokenized oil futures, we actually have 3 regimes going on. We can have a CFT regime that is going to regulate the oil futures and, of course, the DEX, because they're going to they'll be particular about how these futures are traded, right? And in this regime, you'll have transaction monitors, contract certifiers, and an identity keeper working. You'll also have the SEC regime, right, that is regulating the tokenized Apple stock and also the DEX, right? And then all these things are subject to BSA, right? So all the actors here are going to be following the underlying BSA regime. And they're all operating together. But one user can go through one customer identification process. They go through, go to one website, show their ID, and do all that jazz one time, and they get all these credentials. They don't even know that they're getting 3 credentials at once. They don't have to think about it, right? The identity keeper will just give them all the credentials that they can, and then the user can just go call any of these smart contracts as they want, right? And similar from the contract certification process, right? You're creating the DEX. Like this DEX here can go to one contract certifier and get all the classifications in each of its regime. Yes, I'm a BSA compliant DEX. I'm an SEC compliant DEX. I'm a CFTC compliant DEX. I receive all the credentials, one process. I'm good, right? Now, what's cool is this also works internationally, right? So I kind of compressed this picture a little bit because you'd still have like the BSA regimes as well too. But yeah, so if you wanted to have a DEX trading tokenized Royal Bank of Canada stock with tokenized Apple stock, you can do that, right? Nothing changes. All right. Now we've talked about how to prevent the deglobalization letdown. I think Nevin's got a little coda here for this talk. So,
thank you, Billy, and thank you, Andrew, for walking us through all the details of that proposal. I hope a good portion of that made sense, and I hope you can see why we're very excited about it. You'll all be quizzed. We have a 16-question quiz that'll be happening during the roundtable section. No, that's not true, but there is a roundtable discussion, a whole hour for this topic later this afternoon. And I would love it if anyone who's really interested in this comes to ask your questions, if you have questions, or if you have any concerns with this. This is an excellent forum to raise them and discuss them with us in detail. So let's kind of step back and think about what the properties are of this system. So one important property of this system, as you can see, is having competitive markets for all these service providers in the system. This is intended to not replicate the situation we have with like the DTCC, where you have kind of a single company that's performing this essential function. Rather, you have a competitive market for every single part of the ecosystem. So if any part is becoming inefficient or overly expensive or anything, then the forces of competition can handle that. Another property is the strong privacy guarantees coupled with the robust transaction monitoring apparatus. This is something where we did not know if we could figure out a way to couple both of those things together. They almost seem like they're fundamentally at odds, but through this sort of magical power of ZK proofs, we think that really is possible. So even if the industry doesn't land on exactly this system, we think it's a really cool proof of concept to show that, like, no, you really can get both of those things at once. We think it's really cool that it's easy for new users and smart contracts to join. And I actually think that it's also technologically easy for new regulators to join. So Billy talked about this being used in an international context. You could imagine this starting in the United States, and then over the course of time, more and more countries using this same basic language. They could still impose their ideas about exactly how to regulate, but as Billy showed, you can have sort of composability of those different regulatory regimes. And so it's not something where we have to convince the entire world to get on board with this at the beginning. You can start doing it, and other countries can decide to join over the course of time if they want to. It preserves DeFi's composable cross-border ecosystem, And it works across all permissionless blockchains, right? So it's not just that you go through KYC once per blockchain. You go through KYC once, and then you have this portable digital identity that you can use in many different environments, which we think is really cool. In terms of the policy elements, if you think about this from a policy perspective, what are sort of the important policy premises? Well, one is the separation of CIP, which stands for Customer Identification Processes. It's like the checking your ID part of KYC. You're separating that process from transaction monitoring. And I actually don't know if we said it out loud during the presentation, but one of our policy proposals here is that a single company cannot be both an identity keeper and a transaction monitor. And this is sort of akin to, in the current regulatory rules for securities trading, there's certain types of functions that you cannot combine. I don't think you can be an exchange and a custodian at the same time, for instance, because of certain conflicts of interest. And we think the same sort of logic can apply here, where it's a very natural way to make it so that if an identity keeper gets hacked, all that's discovered is people's personal identifying information, which is not good, but you're not going to see all of their personal information and all of their transaction history forever. Similarly, if a transaction monitor gets hacked, you only get access to pseudonymous transaction information, somewhat akin to what we already have on public blockchains today. So that really reduces the risk, we think, both of what any given company can end up doing with its data monopoly, but also what happens in the inevitable case that some of this information ends up being leaked. Another element is making on-chain identities fungible and Sybil resistant. As Billy talked about, it's possible, we think, to make it so that when you go sign up with an identity keeper and then you go trying to sign up with another identity keeper, they have a way of checking and making sure that you're not creating multiple digital identities with the same government document. And so that makes it so that that actually embeds a degree of Sybil resistance into the system. And as I'm actually going to touch on later today, that's useful not just for regulatory purposes. We think that has really positive implications for DeFi governance overall. And then in the interest of time, I'm gonna skip over the last of these. The progression that the Digital Securities Initiative has taken so far was to first spend quite a lot of time thinking deeply about, how could we do this? Is this even possible? We didn't know if it was going to be possible or not when we set out to doing it. You might wonder, where's this going to go next? So after thinking this all through, we spent a good amount of time meeting with industry policy experts, folks who've been sort of staring at these problems for many years, wondering, what could we do about this? Folks who, when you sit down and give them this presentation, their eyes really light up because they're like, oh my goodness, this might actually solve all the problems that we haven't figured out, how to fit them all together. And we've gotten very, very good feedback from about 5 heavy hitters in DC who are the exact type of folks who really understand this deeply. Our next task was to have initial conversations with regulators. So we've spoken with the Department of the Treasury, including folks from FinCEN, and we've had our first meeting with the Securities Exchange Commission Crypto Task Force. And I would say that the main takeaways from those 2 meetings were, from Treasury, essentially no discovery of any sort of show-stopping issue. In terms of the basic functionality that this provides, it seems like the initial conclusion was yeah, this seems to provide the important basic functions, and that's what we were there to check. Is there something we're missing that we're not giving you that's really essential for your process? And from the SEC, Crypto Task Force, I would say what I took away from that meeting was broad enthusiasm and confirmation that this is the type of thing that the task force is interested in seeing the industry try out under some sort of innovation exemption. And so our next stage is to, as you saw in how the system works, this is not something just one single company would build. This is something that many different companies of different types each play their own part, right? So you need wallets, like Phantom and MetaMask to implement this sort of technology to construct these ZK proofs. You need on-chain transaction monitoring companies like Chainalysis or Elliptic to play this slightly different role in how, how they're contracting with companies and monitoring transactions. You need DeFi developers and security token issuers to implement these transaction filters in their smart contracts and so on. And so what we're doing next is having quite a lot of conversations with industry participants to search for a handful, probably, I'm thinking about 5 companies to build a prototype version of this under an innovation exemption is what the SEC is calling this possible concept. And we'll talk about that more a little bit in the next session. We'll not be talking about the DSI proposal, but about the task force innovation exemption approach. And so if we can do that, we think that we can really show concretely what it would be like for this system to operate in practice. And so our ambition is that this will be the way that the future financial system works, right? This will operate in addition to the way that the current tech stack with Reg NMS operates. This could be an additional parallel system that would really make it possible to do everything we want to do in DeFi and satisfy the needs of all the users and developers and regulators alike. Later today, there'll be a 1-hour roundtable discussion to dive into this in more detail. If you guys are interested. So thanks for coming. Hope you appreciated that presentation of DeFi market structure. Thanks.